Today we're going to start the series on MapReduce, and before we start MapReduce, we're going to be looking at collection organization in NoSQL. This could also be file organization if we're using something like Hadoop. But in the context of this MapReduce series, we are going to be looking at aggregates. So we are going to be looking at MapReduce if we apply it to aggregates. There are many other applications of MapReduce, but this is going to be a useful one, I think, for people on this channel to kind of get an idea of what's going on. If you are coming from the SQL world, where you come from table structures, especially SQL table structures, you have table structures that are built off of relationships with each other. So you have tables that are linked to other tables. It's kind of like this, where you have multiple tables, and each of those tables have a relationship with each other. Imagine pointers pointing to each other. So you have like the snowflake schema, the star schema, etc. Okay, so you may have, let's say, a home, and that links to a home ID field, which links to a home cell ID field, and there can be a many-to-many relationship because one home can be sold multiple times to multiple people. Okay, and you have relationships between all of that. In something alongside of, let's say, NoSQL collections, we don't spread out our collections like we do tables, and in fact, a non-NoSQL developer might try to develop collections like this, which is incorrect. That's not how we build collections. Okay, we might have a lot of those relationships all within the same collection. So let's say, think about documents within a collection. A document, if we were selling a home, may have the home address, right? And it may have the entire history of buys and sells, and that would be a sub-document within that document. We're not going to sit there and try to link it to another table. That's not something we're going to do at all. You could certainly do it that way, but that's a novice approach. And then, of course, you end up in a problem. For instance, what would happen, and by the way, this is where SQL really costs money. What happens if you need to horizontally scale this? So what happens if from the beginning your SQL developers did not think, and this is very common, again, I've seen this in companies, what happens if your SQL developers did not think about horizontally scaling from when they set up your database design? Probably the biggest mistake that I've seen in a lot of companies and just with a lot of clients. From the person who developed the schema of all of the different tables did not think about what happens if we need to scale this horizontally to where we can run parallel processing, to where we can run parallel queries, where we can run various things in parallel, or we want to horizontally scale by, let's say, time. We don't have all of our reports always hitting the same time periods. This becomes very complicated to scale. And just as a case in point, I would say just in what I've seen in environments that have to do this, if they use SQL, almost always you're looking at $500,000 that they lose. Whereas in MongoDB, I could scale that in one day if it was built right. There's no way I could, even if it was built right, there's no way I could do that in SQL in one day. But in MongoDB, I could do that in one day. So here's a document structure that we've already looked at in MongoDB in this collection. And both of these documents would be in the same collection. And some people might ask, again, in the SQL world, they look, but those are different structures. Why wouldn't they be in different tables and in different collections? And the reason is because these both relate to exercises in this example here. Okay, this is a contrived example. We don't want to put them into other tables, right? Because, or other collections, I should say, like we would do in SQL Server. In SQL Server, yes, we would probably, let's say if I was doing this in SQL Server, I would probably have, let's say, on the one on January 2nd. So I would have a workout ID and I would have a date. And then the workout ID would link to a table that is structured with weight and reps. And then an exercise ID, and the exercise ID would link to a table that has like a lookup table with what are these exercises, right? And so then in the actual exercise table, there would be the exercise ID, there would be the workout ID, which would be the date, there would be the in that table, then you'd have the reps, and then you'd have the weight. You can already see there's at least 4 tables, okay? Oh, but jump rope is a different type of exercise, okay? So I'm going to need a table that is, let's see, this is a time limit that it has to hit. So there's going to be an exercise time limit table. So then there's going to be the workout ID is going to be linked to that. Also, does order matter? Because if order matters, I'm going to need some type of order table to know that the pull-ups occurred before the jump roping. And maybe it does and maybe it doesn't, right? And then we get into the farmer's walk, et cetera, et cetera, et cetera. You can see the complexity of, if workouts can be very dynamic, and they can, it's going to be really hard to store all of this in SQL Server without getting into 50 to 100 tables. And by the way, I did try a fitness program for myself one time, and looking at all the different workouts, I came up with about 125 or more tables that I would need. Maybe if I pushed a lot of the data unrelated together, I could get to 50, but yeah, it was a lot of tables. I was like, this is not worth it. Okay. And then we look over at the other one and we have sprint day, totally different. And then we see pain 1. So we're noting when we're in pain. So then we can add things to this approach. Okay, so why would these be in the same collection? And MapReduce, the reason why this is a precursor to MapReduce is because MapReduce is going to help us break things down, right? So, but in order to break things down, we have to have things together, right, before we do that. So why would these be in the same collection? Because they're exercises, right? Because they're related to each other in that way. These data are related by IDs. We're using these IDs to link data together. That's not what we're going to do in NoSQL. We're going to keep related data in the same collection. And if we need to scale things, we're then going to scale from that collection to other collections. I'll give you an example with exercises. Let's suppose we really ended in a situation, it's unlikely, but we ended in a situation where we had a ton of data with exercise. Or let's say it was, health. We called it health. So it involves food, exercises, and just health-related things like going to the doctor. So we have this huge database, right? And we get to the 7-year or 8-year point, and our applications are running very slow. So one of the things that we can do is let's horizontally scale by time, right? So let's take all of the data from, let's say, 2017 and 2018 and 2019 and 2020, and let's put them in different collections. My application does not have to change in terms of the structure, and it is the structure of the application that fundamentally will determine the schema when it comes to NoSQL. My application does not have to change. The only thing I'm going to need to change in my application is some type of entry where it's like, okay, now that I've scaled by time, the user is going to select a time. Let's say if the user selects a report for 2016, it's going to go hit the 2016 collection. If the user selects the 2017, it's going to hit the 2017 collection. But I don't have to change anything else other than that. Whereas if I try to scale this by time, okay, well, the one-to-many tables and the many-to-many tables, I have to bring those over, right? I have to bring up the lookup tables. I have to bring the many-to-many tables. And remember that some of the many-to-many relationships may be formed in one year and not the other. Same thing with the one-to-many, right? And so, and I've seen a lot of people who develop archiving solutions for this type of situation when they're horizontally scaling because it wasn't thought out at first. So when they get into that many-to-many or that one-to-many, they're overwhelmed because they have to determine which many-to-many or which one-to-many, and the way the data were built on the schema side, it's not very easy to determine that. And so that's where a lot of times people say, okay, well, we can't do it this way, so let's partition by a big table, right? And that's where you start getting what I consider to be very limited solutions. That's not truly horizontally scaled. You've now just taken one piece of that and scaled it. NoSQL, in this case, when you have data like this, instead of building 150 tables, which is just going to be, first of all, a lot of work, and then it has to be designed very specifically so that it scales appropriately if we're going to be in these situations. Now, note that not all situations are going to be scaled accordingly. And also note that this right here, going back to this over here, this is not like a market structure, right? If we're looking at an invoice application, it follows a set structure like this. And so from the very beginning, that should be fairly easy to scale. It's the same thing with stock data. Fundamentally, stock data is just date, price, and simple. And then, of course, we add all these derivatives like the open price, the close price, the adjusted price, etc. But that's a pretty specific structure. This right here is not. And we could flatten this out to where we have 350 tables, 120 tables, 150 tables, just 50 tables. But in reality, it makes a lot more sense for something to be in a NoSQL collection, and then we can scale accordingly as we need.